Hello everyone. In the previous video, we have discussed about Norton's theorem and also that is source transformation. Okay. Now in this video, we are going to discuss about reciprocity theorem. Okay. At the end of this, you will be able to state the reciprocity theorem, explain the reciprocity theorem, and also apply the reciprocity theorem to the electrical circuits. Okay. Now, just to recap what we have learned in the previous lectures. Already we have discussed this one, and this also at the end of this video, this lecture, these are the outcomes: state, reciprocity theorem, explain, and apply. Okay. Now we'll see the statement of reciprocity theorem. What is reciprocity? That is the statement. So reciprocity theorem states that if an EMF in one branch of reciprocal network produces a current in another, then if the EMF E is moved from the first to second branch, it will cause the same current in the first branch, where the EMF has been replaced by short circuit. Okay. So that means here in one reciprocal network, so EMF it is there E, okay, either E or V, whatever it is voltage. So at that time it will give some current, it will produce the current. After moving this EMF to the next branch, this EMF place you are changing, that is by replacing with short circuit. At that time also you will get same current in the first branch. Okay, that is the meaning of this statement. Same theorem, we can give another statement for this, or reciprocity theorem states that if we consider two loops A and B of the reciprocal network A, and if an ideal voltage source E in a loop A produces current I in loop B, then an identical source in loop B will produce same current I in the loop A. So in this way also we can state this theorem, either first statement or second statement. So this one clearly you can understand after explanation and with the example problem. We'll see in the next slide. Now we see, only thing is here, once you are taking an EMF, at that time how much current it is producing in the particular branch. After moving this branch to another branch, so at that place we have to short circuit in place of that source and shift this EMF to the another branch. At that time how much current we are getting, so this current and that current it is set. That is the meaning of this after replacing that also. Okay, now we'll see that. So this is the explanation of reciprocity theorem. You see here a voltage source and a meter. We are taking here, one is voltage source, another one is current source. That is called generally measured by meter, it is called ammeter. Ammeter is used for measuring the current. Used in this theorem must be ideal. Both sources, you can say here, either that reading whatever the values, those should be ideal condition. That means the internal resistance of both voltage source and this ammeter must be 0. That is the first condition it should be. Okay. The reciprocal circuit may be simple or complex network. You don't know how much it is. That is whether it is simple network or complex network. But a very complex reciprocal passive network can be simplified in simple networks. By using this, we can simplify the network. Okay. As per the reciprocity theorem, in a linear passive network, supply voltage V and output current are mutually transferable. That is the meaning of this. What you are taking? So, one case you are taking voltage in the first branch, for example. When you are shifting that side in place of that, so both the cases you are finding the values. It should be same. Okay, but these elements, whatever you are talking about, sources are shifting here. First branch to second branch. So supply voltage and output current are mutually transferable. That is the meaning of this reciprocity theorem. How to find out that, we'll see the steps here. So the ratio of V and I, V by I, is called transfer resistance. Transfer resistance. Now we'll see the steps for solving a network utilizing reciprocity theorem. First step. Firstly, you have to select the branches between which reciprocity has to be established. You have to select, that is up to you. You have to decide which one it is. Sometimes it may be simple network, sometimes it may be, you have to decide that one. You have to select the branches between which one you have to shift the source to one place to other place. Second, the current in that branch is obtained using any conventional network analysis method. You can take either nodal analysis or loop analysis method. Any method you can use. You need to find the current in that particular branch. Which one you are selecting, in that branch you have to find the current by using any one of the method. Third condition is the voltage source is interchanged between the branch which is selected. After selecting that one, first you have to find out the current in that branch, and then you have to shift that source to the next branch. Again you have to find, that is also you have to select, right? So after selecting that, again find the current in the branch where the voltage source was earlier existing is calculated. The first one already we found. Again after replacing, that is a shifting from one to other. At that time what we are taking in place of voltage, we are keeping that is short circuited. So at that time we are finding the current in that branch. That is only meaning of that. Okay, in that branch you have to find the current. Okay, now after finding this one, that is the second step, and fourth step, both are the current finding only. Current in the branch using the first method, and that is any one of the conventional method. In this case, here again after shifting the source, voltage source, again you have to find the current. So then we can, so second source, that is the second step current, and fourth step current, both should be same. That is the meaning of here. You can see here, now it is seen that current obtained in the previous connection, that is a step 2. And the current which is calculated when the source is interchanged, that is step 4, are identical each other, both are same. Okay, in this way, you have to find the, use the reciprocity theorem to the electrical circuits. You have 4 steps here. Fifth one, it is just for conclusion type, right? So first one you have to select branches, which one you have to take this reciprocity. Second, find out the current. So you have to use, you can use any method, there is no restriction for that. Any conventional network analysis method you can take, either nodal analysis or loop analysis, mesh analysis you can take. And third case, again you have to shift that source to the next branch, which one you have selected. So again we find out the current in the previous branch, that is wherever we are finding with the source. So in that same branch you have to find the current and then compare with step 2 and 4. Just compare with 2 and 4, automatically both currents will be same. Okay, then we'll see the examples. The theorem can be understood by following example. Very simple example. You can see here we have two figures here. Two figures. First figure, what is there here? This is the source, voltage source. This is the entire network. Sometimes it may be simple network, sometimes it may be complex network also. And this is the current value, that is a current source. You can see here, that is ammeter I mentioned, right? So we are using for measuring the current value. Now what we are taking, so this one, first we are finding the current value by using conventional method, and then this one we are shifting to this side in the next branch, right? This one it is shifting to this one. So again we are finding current here, we are replacing with the short circuit. Just current we are finding in this branch only, that is the current. So then this current, whatever the value we are getting current, and this same, these two are same. That is the meaning, because here you see here voltage source is in the between A and B, right? After moving to the next, that is called, so after finding the value of current here in the circuit, then after moving to this side, that is the shifting from here to A to B, between terminals A to B to C to D here in this case, right? So after shifting this one, again find out the current here only. This is the previous one, right? Because in between A and B only now the voltage source, actually that is the previous case, this case. So in this branch only how to find the current at that time. So this current and this current, it should be same, that is this. So the ratio, you can say, if the network we interchange the positions of response and excitation, then the ratio of response to the excitation is constant. Okay, that is, so ratio of voltage to current, because here you can see here, this is the source, right? And this is the, which one, this output only you are getting current. At that time how much you are getting this value. So position of this one, after taking that response to excitation, what you will get here? So I by B. Okay, that should be constant value. Ratio of response to the excitation is constant. Can you see here? IL by IS. This is supply source. If you are taking supply source, and this one it is a load current, right? That is the value. After shifting this one, after shifting this side, what we will get here? This is the load side, right? Once you are taking, that's why I am taking here. This one it is real, and this one it is the actual one, it is source side at that time. So IS by real. So this ratio should be constant. Now we'll see one example here. Find the value of current in the given network. Okay. So how to find out this value? This is a very simple example I have taken. Why I will say that? Now this is the circuit. This is very simple circuit, a linear network. So this network, linear as a network, source it is, this is the source, voltage source, right? 10 volts. And by using this one, I am not calculating much here. Simply how much current it is flowing here, that is a 5 amps with the help of this source. I am not taking any conventional method. Very simple example I have taken here. So 10 volt source, it is producing this 5 amps current. Okay. Now by using which one? Reciprocity theorem. By reciprocity theorem, then the circuit, because what you have to take after finding the current, by using any conventional method. Here already it is given, that's the reason we have not taken any method. Then replace this one by this, right? So this source we should replace. We have to find the current value. So what I have taken, in place of this, what I have taken, I am replacing with the voltage only, voltage source, but that value I increased. Okay, why I increased? You have to find the current. If I am keeping directly same voltage source, how much you will get, that easily you can find out. Already we have shown that, right? By using simple conventional method, we can find out. But here, why I have taken it is a, by seeing it is a very simple problem. The thing is here you have to observe this, because here I have to change, I changed 30 volts, and how much current, this you have to find out. In what method you can take here? Just now we have taken a simple formula. Just you see here, just last step, you have to use that ratio constant. So you have to use that one. For that reason I have taken one simple formula here. You can see here. Yes. Okay. So in the first figure already we know the current value, that is this 5 amps by 10 volts. We know this one. We are comparing both the circuits here. And second case, we don't know the value of current. We don't know value of current, but we know this one. Which one? Voltage. I by 30. Okay, I by 30. Why you are taking this is in this direction, and this one it is this. In this, right? Reverse it is. That's the reason I have taken minus I by 30. Just cross multiply here, 30 into 5, 150, 150 by 10 is 50. Very simple problem, but very important problem is this. Generally, it is a short answer problem only. But nowadays, this reciprocity theorem are not using for many applications. Rarely using theorem nowadays. Okay, that is a main. It is clear from the figure above that voltage source and current source are interchanged for solving the network with the help of reciprocity. Because I have taken one simple problem only, I did not taken much, because this one it is not that much important. Nowadays they are not using this theorem for all the applications. Okay, olden days it was a very important theorem, but now it is a rarely used theorem in the electrical circuits. Okay. The limitation of this theorem is that it is applicable only to single source networks and not in the multi-source network. That is the main drawback of this one. Because whatever the network you are taking, only applying single source, but many people they won't use for applications, different applications you have to go for the multiple sources. Sometimes it may be voltage, different sources, V1, V2, V3 and so on, or sometimes combination voltage and current sources. Okay, that's the reason. But this, why it is drawback, that is a why you are not using in many applications, because of this reason only. It is applicable only for single source network. Okay, that is the main. The network where reciprocity theorem is applied should be linear and consists of resistors, inductor and capacitors and coupled circuits. Because already I told it is applicable linear passive network, right? Linear passive. Passive means these are the elements of resistors, inductors and capacitors. The circuit should not have any time varying elements. Okay, it should be time invariant only. It is applicable for only linear time invariant passive network. Passive network. Okay. Now, till now we have discussed about reciprocity, sorry, reciprocity theorem, statement. So, how we are using that one? Already we have taken that statement because once you have to take source because it is applicable for only single source networks. Apply the source, find out the current by using any conventional method, and then move this source to that selected branch, and then again find the current in this branch, in the previous branch. After that, compare those currents, previous one and this one, it should be identical. That is the statement actually. After that, we have discussed about explanation of reciprocity theorem, and then finally we have applied for the very simple application, that is to the electrical circuits. Okay, thank you for listening.